All right, so this section is about linear inequalities. An inequality means that it will have an inequality symbol. I have these written out ahead of time for each of the symbols. So notice we have less than. We have less than or equal to, which includes this line underneath that. That's saying that whatever number is in my inequality, whatever number is there means it is included in that inequality. And then I have the greater than and greater than or equal to. All of these are important to know. If you have a hard time remembering which one's less than, which one's greater than, if you will hold your hands out in front of you with making sideways V's that look like less than or greater than, then you can see that your left hand is less than and your right hand then is your greater than. It's important to be able to read an inequality to help you understand it for graphing purposes and when you're using interval notation. Now we are going to use some symbols here for interval notation. We're going to and for graphing, parentheses and brackets. We use parentheses if it's just greater than or greater than or less than. We're going to use brackets if it's less than or equal to or greater than or equal to. And I'm going to use those on the graph as well. Now the parenthesis that we'll use for greater than is going to open toward going to that direction, greater than the number 5 in this case. And then we're going to draw a line on there showing that we're going greater than 5. The 5 is not included in this case. Now this notation is called set builder notation, and it's basically saying that all values x such that x is greater than 5. So when we're looking at this, here's the part that we're most concerned with. What does that say? Well, it says that x is greater than 5, and that's how we will graph it. Now you can put more numbers on your graph if you would like to. I usually just put the number I'm graphing and then to the right or left, whichever direction I'm graphing in that case. On my lab, you will see that, you'll have to make sure you understand where it goes because there will be the marks on the number line. When we put this in interval notation, it's basically going to help a lot looking at the graph, because this says that it goes from 5 to infinity, and this is called interval notation. This is a way to write the solution set. If I looked at just this, I would know, oh, I'm looking at interval notation. This is everything from 5 on, or not counting the 5, right? The 5 is not included, and goes all the way to infinity, which of course just continues on. Now let's look at this next one. This is the part we're concerned with, but notice that the x is on the right. That can sometimes be confusing. So really you would want to rewrite that with the x on the left. That makes more sense when graphing. You can read it backwards, starting with the x. This says x is less than or equal to -7. And I'm going to write it that way, less than or equal to -7. Sometimes if you leave it written in this form, you may graph it in the opposite direction than it needed to be. So this is less than or equal to. So we're going to use a bracket facing the left because we're going less than. And please draw your lines here. I know that on my lab you don't necessarily have to do that. A lot of times you're just choosing these from multiple choice, but it needs to have that line. It needs to show, okay, I'm going this direction with an arrow. Now when we write this in interval notation, we have to talk about what's happening on the left first, right? We're going to negative infinity, and then it stops at -7. So when you write a negative infinity, it always has to be written on the left hand side, -7's on the right, and we use the bracket then to show that's my stopping place on the graph. So this negative 7 is included in the solution set. So you could just name all kinds of numbers in this solution set, negative 7, negative 7.5, negative 8, negative 9, and so on. All of those are numbers in the solution set. Now these are called compound inequalities. And really, when you look at it, you can see x is between negative 5 and 1. Both negative 5 and 1 are included because it has or equal to. And this is the part we're concerned with. So here's how we would read this. X is greater than or equal to negative 5 and x is less than or equal to 1. If it helps you, you can just say, okay, so x is between negative 5 and 1, and they are both included in this case. So I'm going to use brackets on the graph at negative 5, a bracket at 1, whoops, come back, and then everything in between. I have some glitchy thing going on, so I'm going to pause for a minute. So I had to go back and try to fix some weird glitches that I have sometimes, and so I had it paused to do that so I could get it to write the way I want it to and not disappear. So what this is saying is from negative 5 to 1, and my interval then is simply that, I don't want my line, from negative 5 to positive 1, and everything in between. So there are a lot of numbers in this solution set. It's not just negative 4, negative 3, negative 2, 0, negative 1, 0, and so on. It's also any decimal or fractions between negative 5 and 1. So you literally could go on and on and on naming numbers in this solution set. Okay, so let's look at this next one. Here's what we want to look at, but you can see that it doesn't look quite the same as the other one. When you're writing a compound inequality, you always want it to go from least to greatest, and it should only have less than signs. So we're basically taking this and kind of just flipping it over to, right, flipping it sideways. It should be negative 7 is less than or equal to x is less than negative 3. What that really says is x is greater than or equal to negative 7 and x is less than negative 3. In this case, negative 7 is included, but negative 3 is not. And then of course we're going to draw here, and that's then graphed. My interval notation is going to be from negative 7 to negative 3, and then that's it. Okay, so here's a few, several in fact, graphs showing x is less than a, x is greater than a, x is less than or equal to a. And so this is just a way to look at the set notation, the graph, and interval notation and how they're all related. You should be able to take any one of these and then draw the other two, or write out the other two based on that. Notice that we only use parentheses when we enclose infinity or negative infinity, because you can't include those, right? That's not just a number. So you might want to pause here and just look through this information. This is from the textbook, and so it's right there in your textbook if you want to look at more. Okay, so now we're going to be solving inequalities. In this first example, we're going to use the addition property. The addition property basically says that we can add the same thing to both sides of our inequality and it will be equivalent, right? So we get an equivalent inequality. Now, when I'm solving these, I want my x on the left because that makes the most sense when you are graphing or writing your interval notation. So I'm going to begin with subtracting 6x, and then I bring down what's left. All right, so then I'm solving for x, so I went to, I should have that as a 1, not as a 7. So now I have x minus 1 equals negative 1. I'm going to add 1 to both sides. And now you didn't do anything incorrect when you get a 0, and 0 is really okay. It's just saying that x is greater than or equal to 0. And then I'm going to go over here and I'm going to graph it. Now, I talked about you can mark your number line if you would like to, right? And so if you did this, you just put a few numbers on here. This is more what it's going to look like. I have those kind of off there a little bit, kind of lowered from the other ones. And so this is what it would look like if you were putting this on, or looking at a graph on my math lab. It would have it listed with some integers labeling your number line. And then when you graph this, we're going to graph greater than or equal to 0. Kind of missed. And then we go to the right. Take that one off with your arrow. Okay. And so our interval notation is going to be 0 to infinity. And that's what that looks like. If you should hear some weird noise in the background, my pug is laying on the chair right here, snoring like crazy. So he snores a lot. Okay, continue on. I'll go ahead and solve this one, and then I'll probably stop the video and then pick it up on another one. On this, we're dividing to solve, and if we divide by a positive number, then there's no special thing we have to do. But if we divide by a negative number, then that switches the meaning of this. So dividing by the negative means I have to learn part of that is to switch the direction of my inequality because of what happens. So let's just say we had 2 is less than 4. Right? If I divide by 2, then I get 1 is less than 2. And this was a true statement initially, and it is still true. 1 is less than 2. But if I said divide by a negative 2, then I would get that negative 1 is less than negative 2, and that is false. So the only way to make that true would be to say negative 1 is greater than negative 2. Notice I have to switch the direction of my inequality because I introduced that negative number in there. And that's going to be the case when solving. Now you have to remember this, and if you forget to switch it, then you're going to have this going all in the wrong direction. So we're going to divide this by negative 4. And then write it as x is less than or equal to negative 2. And then of course we just graph that at negative 2. And then we will write our interval notation based on our graph, right? So this goes from negative infinity to negative 2, and a bracket on the negative 2 because it is included in my solution set. Remember that we always use parentheses on infinity. Negative infinity has to be on the left-hand side in your interval notation. Positive infinity will always be on your right-hand side. All right, so I'm going to end this video and pick this lesson up on the next one.